Hello everyone and welcome back to another lecture of machine learning techniques. This is lecture 9 and today we're going to be learning about the perceptron algorithm. So for a very long time researchers and engineers have been trying to model the human brain or trying to make a computer similar to a human brain. Well, to go back to a bit of biology, our brain is made up of billions of neurons. The input is through electric signals that are called dendrites. They're processed through the nucleus and the output is through an axon. So what if we can mimic this through a computer or through an algorithm or make a machine learn in a similar way? So this is called a perceptron algorithm. So let's say we have lots of inputs, x1, x2, x3 and so on, which are the features, and then each of the feature carrying some amount of weight, which is later on summed with a bias, and this, when given to an activation function, decides if the output is a 0 or a 1. This is a similar structure to a nerve in our brain. So how does the perceptron think? So first we have the weighted sum, and then we have an activation function, which is basically a non-linear function, which basically says if z is greater than or equal to 0, then output is 1. If it is lesser than 0, it is 0. This analogy here is very simple. Let's say the x1 is your favorite band playing, input 2 is the ticket expensive, and b is your mood. So excitement score in the end is the amount of weight you applied for your favorite band and the amount of weight you applied to the ticket being expensive and your general mood. And if your excitement is still positive or greater than 0, then you book tickets to the band that is playing. So now, but the brain always learns through its mistakes or adapts. How does this algorithm do it? Well, we have different weights. We do not know what are the weights for the inputs. So we start with random weights, but not the same weights, random. And then we feed in a training example. We compare the prediction to the real label, which is basically supervised learning. And then we update the weights based on how wrong or tweak the weights in the right direction. So the formula is basically the new weight is the old weight plus the learning rate into the target or the actual class minus the prediction class into the input. This is the basic formula of learning. So now what are the limitations of perceptron? The biggest limitation of perceptron is that it is a linear classifier, which means it can only draw a straight line. We saw this in the previous lecture with an SVM, where SVM is only possible for linear class, which is why we use a kernel function and make it into a higher dimensional space. So how do we solve this? We solve this through something called a neural network, which is if more than one neuron is present, then it can even adapt to non-linear data points. So in short, a perceptron is a single artificial neuron. It uses weights and bias. It uses a step function, which is called an activation function. But the problem is it can only solve problems that are linearly separable. Next, we'll move on to neural networks, where we actually model the brain into complex networks that make decisions and is very, very powerful. Thank you and see you all in the next lecture.